in elimination and anti-elimination. In syn elimination, there is a repulsion between the what we can say that leaving group. If any base attacks, so there is a repulsion. But in antiplanar elimination, we are having, when base attacks, no repulsion. Right? So this is the reason we will say that it will happen, but there is a little probability of this repulsion, because of repulsion. Right?
Yes, ma'am.
So after that, mechanism also discussed about E2 reaction. E2 reaction mechanism, rate, reactivity, regioselectivity. Regioselectivity means major or minor. Stereochemistry is anti-elimination happens. And if we take an example of anti-elimination, so we did take and discuss about that example, right? An example was that. What was the example? Where we are having this type of pH, CH3, Cl, pH, HH. So we have drawn the Newman of it. pH, Cl, H, CH3, H, pH. We want this leaving group and hydrogen, beta hydrogen, to be opposite to each other. So we are rotating it to 60-degree angles. So while rotation with 60-degree, H, CH3, H, Cl and H eliminates out, and we are getting a structure to be like this: CH3, pH, H, pH. Now we can show it to be like alkene, having pH neighbor to each other, H, CH3 like this. So this is the cis form we are getting, right? Cis alkene. Correct, na, Himansh?
Yes, ma'am.
And another example, we have taken H, CH3, Cl, H, pH. So this is actually trio form. This is known as trio form, and the previous one was erythroform. This was the erythroform. So erythroform, where the HH are same side, and trio form, where it is on the opposite side, we are getting the trans alkene. We'll do the same thing over here as well. We'll get the trans alkene. Okay, and so dehydrohalogenation. It is stereo, specific and selective. Stereo, selective. Selective means to tell that which one is major and which one is minor, and specific means anti-planar, major and minor, and specific means anti-elimination is happening now. So this is specific, that elimination happens only when they are anti to each other. So we have taken example of anti like this one. So if CH3 over here, so X over here, so this will eliminate which type of hydrogen? It will not eliminate this hydrogen, but yes, it will eliminate this hydrogen. So we will get accordingly this type of alkene. Right?
Yes, ma'am.
After that, we did discuss even reaction. Even reaction. In even reaction, actually what is happening? We are having XH, ETOH. So alkene. So mechanism of the reaction is of two steps. Step number 1, where we are getting a carbocation. And the second step, step number 2, we are getting elimination of this hydrogen out. So when it eliminates, we are getting double bond. So the first step is the slow step, and this one is the fast step, where the base attacks over here and it eliminates out. So rate is basically depending only on the concentration of alkyl halide, not on the base. So that is why we will say that order is equal to 1 and molecularity is also equal to 1. So we are getting a carbocation over here. That is the main step of the reaction. We draw the energy profile diagram of it. The energy profile diagram is like carbocation and product. This is the energy profile diagram. We are having over here reactant RH, carbocation and alkene. That is formed over here. So this is transition state first, this is transition state second. Right? So intermediate is carbocation. So since intermediate is carbocation, so we can say that possibility of rearrangement is possible. Rearrangement is possible. Right? Example is that, like, the question might be like, they are giving you an alkene and they are asking that alkyl halide, they are asking number of isomeric product. Isomeric product. So you have to be like, first of all, you have to eliminate the Cl out. You will create a carbocation according to that. Now, after forming carbocation, there is two possibility. Like either you can create a double bond over here or over here. So these are two products, but after the rearrangement, you can also do the rearrangement 1,2 hydride shift. Due to hydride shift, you are getting this type of carbocation. Now when you form that alkene, you will get either this one or you will get either this one. So they both are same only. So we are getting overall three isomers over here. So 3 will be the answer, 1, 2 and 3. So there are 3 isomeric products in this category. Right, Naimansh? Any problem?
No problem, ma'am.
So we can say here is different possibilities we are getting, ETOH and T2. Since we will say that even reaction are stereospecific. Stereospecific means stereoselective. Selective means major minus. Selective means major minus. Major and minor product. But not stereospecific means it is not specific. It is not mandatory that anti-elimination always happen. It can be any. Right? Example, we already discussed one more example, that this one, Cl. So when we do the elimination, number of products, ETOH, P. So when we do the elimination, we are getting this type of carbocation. When we get this carbocation, we can either form alkene to be like this or this, right? But if we do the rearrangement of it, if we do the rearrangement is like hydride shift. So if we do the rearrangement, we will get 1,2 hydride. No, not before hydride shift, we will do the ring extension, right? See, when there is a possibility, as I told you, I guess, in the rearrangement topic as well, that if there is a possibility of hydride shift and ring expansion, we will go with the ring extension, right? Ring expansion. So you will expand the ring, created a 6-member ring from 5-member ring, and you will get a carbocation like this. So when you do the elimination, you will get a double bond over here or will get a double bond over here, right? And if you do the hydride shift, hydride shift. When you do the hydride shift, you will get a carbocation like this over here, and then you will form two products, one to be like this and one to be like this. So they both are same only. So you will get 1, 2, 3. This is chiral carbon, so it's having 2, 2, 3, 4. 1, 2, 3, 4, 5, 6. 6 overall products are formed, right? Correct, Naimansh?
Yes, ma'am. Correct, ma'am.
After that, what else is the E1CB reaction? Third reaction that we discussed was E1CB reaction. That is eliminating unimolecular conjugate base. Here, what we are doing? Compound to undergo E1CB reaction, there are condition. Condition is like leaving group should be poor, and second condition is that beta carbon have acidified group. Poor leaving group like chlorine, OH, SR2 positive, like this. These are the poor leaving groups. Let us consider an example. Sulfur, this is beta, alcoholic KOH, heat, we are getting Z, CH, double bond CH2. Z group must be minus R effect showing, like that, right? So it must contain something to be electron withdrawing. So mechanism of the reaction was, how the mechanism going? That Z, CH2, CH2X, OH negative, fastly attacks over the hydrogen. We are getting Z, CH with a negative, CH2, CH2X. This negative is a conjugate base, right? By the elimination of H positive, it's a conjugate base. Now conjugate base is stable by the minus electron withdrawing group, right? Getting stable. After this slow step, where poor leaving group, X is a poor leaving group, that eliminate out, and ultimately we are getting a double bond like this. So rate is depending on K, Rx and base. The order is 2, but molecularity is 1. That is the reason. So there are examples we have discussed about it. This is a very good because it is a poor leaving group and it's electron withdrawing. So accordingly we will get this type of alkene over here, right? Alcoholic KOH, heat we are doing over here, double bond O, and over here we are getting this CHCl2, CF2F, CCl2, double bond CH. Then we discussed about another reaction, that is dehalogenation of vicinal dihalides. In that we are having vicinal. Vicinal means 1,2 dihalide like this, and we are adding either zinc, heat, CH3, COOH, and we are getting a alkene, or we are adding NaI, acetone, heat. So again we are getting this alkene. The mechanism is E2. E2 elimination happens over here. Stereochemistry is anti-periplanar. Means if they are anti to each other, then elimination will happen. So basically they need to be like anti to each other, then only zinc, let's say it will give the electron over here, it will move over here and ultimately it will remove and we are getting this alkene. And zinc iodide is zinc or any halide, whatever the halide is, it's eliminate out.
And just we need to remember that this will be E2 reaction. Means how can we say particular will be E1, E2, E1 similar?
Or even as I told you that whenever if a stable carbocation possibility is there, you can go with E1. But here, carbocation is not stable. Got it?
Yes, ma'am, got it.
You know that yes, this example given to you, right? Zinc heat, CH3 cerealoids. So you will accordingly see that Br should be anti-periplanar to each other, right? So this Br should be moved over here, CH3 should be moved over here, and it should be so 180 degree rotation we are doing. When we are doing this 180 degree rotation, here H. Here, over here Br, over here H, CH3, no, it's pH over here, pH, and CH3 will move over here. So we are eliminating this Br out, and we are getting this type of framework. At pH over here, CH3 over here, pH and H. So accordingly we will form which type of alkene? pH opposite, H and CH3 opposite. So we are getting trans alkene. Right?
Yes, ma'am.
That is all we did in the last class, I guess. Right or no?
Yes,
Remember
ma'am.
with this too? Now new topic is dehydration of alcohol. This will also produce alkenes and it is very important. Dehydration of alcohol. So let's say we are having an alcohol like this. What will happen? It will eliminate out in the presence of any acid. There can be concentrated H2SO4, concentrated H3PO4, each P410, right? Al2O3. So they all are working over here as a dehydrating agent and we are getting accordingly alkene, right? Generally 1 degree alcohol undergo E2 elimination. Since in E2 elimination, 1 degree alcohol will do elimination. The carbocation will be formed over here. I'll explain that how we are forming that. And if it is 2 degree or 3 degree, even elimination mechanism is failure. Let's discuss how. Let's discuss about the mechanism of it. So we are having, let's say, a carbocation, alcohol. We are adding H bond. Oxygen contains lone pair, so donate that electron to hydrogen. The oxygen attached to hydrogen and got a positive charge. It is unstable, so it will eliminate out. And we are getting this carbocation in that position. Ultimately, to stabilize the carbocation, this is carbocation which is forming, and whenever the carbocation is forming, the step is slow and predetermined step, and we are ultimately getting an alkene, right?
Ma'am, and this OHCH4 plus takes the 2 electrons from that bond and carbocation is forming, we are saying, ma'am. And this OH2 plus taking 2 electrons of that bond and
Yes, see, oxygen got a positive charge. First of all, oxygen have lone pair, H positive was there. So whenever there is a possibility that one species is deficient of electron, another species have lone pair, definitely it will donate the electron to H positive. Then oxygen got a positive charge over it because oxygen donated that electrons. Now, oxygen will take both the electrons of the bond to get neutralized. After that, oxygen taken that electron, so carbon got a positive charge, this is carbocation. Okay.
moment H2O minus will be formed and this carbocation and then double bond will be formed. This is the mechanisms.
By H2O minus H2O means I have just shown over here that it is eliminating. Minus is not a charge.
Means oxygen. Whenever oxygen takes 2 electrons, got it. Takes and get H2O, got it.
Since carbocation is forming, so we will look for any possibility of rearrangement if possible, right?
Yes, ma'am.
Carbocation if it is forming, that means you have to go for a rearrangement if possible, right? So alcohol, second one, third one, final product. So this is alcohol, ROH2 positive, R positive, and final alkene. So we are getting transition state first, transition state second, and transition state third. Okay, rearrangement very important because this is majorly the thing that requires during the reaction. It is very feasible that see, it's not like they simply ask you to do the dehydration. No, or obviously they will frame the question in a level that you have to go for rearrangement for that. Okay, no? Much?
Yes, ma'am. Okay, ma'am.
That's it. And H positive. Right. Now, what you will do? Just look into the mechanism that operates over here. H positive, oxygen contain lone pair, it donates over here. Oxygen H, one more H, oxygen got a positive charge due to donation. Oxygen leaves out, water eliminate. See, why is it dehydration? Because as you can see, water eliminates, right? Carbocation. Now we will look for a rearrangement because this is 1 degree alcohol. That is less stable. So we will do 1,2 hydride shift. So when we are doing the hydride shift, it's got a positive charge and this will be CS. Ultimately now you will see the positivity. Right? That how to do the elimination. So either this hydrogen or this beta hydrogen can eliminate out. So we are getting two type of products. Or H minus C. Initially H plus enters, now H plus removes. So we can say that acid over here are the catalysts that recover in the reaction, regenerate in the reaction. H positive taken in the first step, and you can see in the last step it comes out. Right or no?
Ma'am, yes ma'am, go.
Out of these two products, we are getting two products, but this is the more substituted. That is a major Setzer product. Major. And this is the minor. Any doubt, Himansh?
No doubt, ma'am.
If I ask you, Himansh, can you try this question or no? Yes, Himansh.
Yes. We can say that this OH negative will be removed and H plus will be formed. Means carbocation will be formed. And then rearrangement.
Ethyl shift will happen, right? Carbocation over here, methyl will be. This will be the alkene which is produced in the major quantity. Another alkene will be in the minor quantity.
Yes, ma'am, because more substituted, more will be the.
Exactly. Okay. Similarly, if I give you one more question. Now tell me what you will do.
Here also OH will get removed and then carbocation will be formed. There will be a shift. Yes, ma'am. Another product will be.
Okay. But one more hydride shift is possible or not? 2, 3, 4, 5 alpha hydrogen. But if I created positive over here, 3, 4, 5, 6 hydrogen will be there. So one more hydride shift will be possible. See, hydride shift is possible until unless we are getting the more stable. So we will create one more hydride shift, although that will not affect the product forming, right? So this is hydride shift, and ultimately we will make a alkene like this. Okay.
Yes, ma'am. Until we get a stable thing, this process will go on continuing, we can say.
Correct. So now tell me what you will do now.
Now also, if voids get removed, ma'am, we get a carbocation.
What happened, Imanj?
Ma'am, here also, if voids gets removed, we get a carbocation.
See, although you are getting the carbocation over here, if you think about rearrangement, there are two, we can say, problems. Okay, if you think about rearrangement, first of all, no rearrangement will happen because it's already 2 degree. So we are forming the alkene to be like this one, because this alkene is now conjugated. That is why we will create this alkene, right? Got it or no?
Yes, ma'am, the next one we'll get as
What happened?
got it, ma'am.
After dehydration, because we know in dehydration a carbocation is forming, right? So we will say that order of dehydration will be 2 degree, 1 degree, right? Agree?
Yes, ma'am.
After that, give me a second, alcohol's done. Let me check if there anything else required for you. Next preparation. Okay. You want to give me a second? Let me save it first. So Imansh, you were asking me about monthly classes. Is the slot is showing to be free to you now?
Yes, ma'am. Now it's showing, ma'am, from yesterday.
Huh?
Yes, ma'am. It's showing free, ma'am. Slots.
Okay. The point is that I'm having a very I'm not taking any monthly classes on Philo platform because of the team and all. So that is the reason I'm not taking it as such, because they are not actively, giving the payouts and all. That is why I'm not taking that on Philo platform. So if you want any doubt learning class from me, so I am having my personal, availability for that.
Yes, ma'am. Okay, ma'am. Yes, ma'am. Okay.
You want it from me? So you can take my, accordingly I will provide you my slot. Okay.
Yes, ma'am. Okay, ma'am.
Okay. The charges they are showing over there for monthly classes, right?
Ma'am, what, ma'am?
How much charges they are showing for monthly classes?
Ma'am, same, ma'am. 3499 for 20. It's showing. Ma'am, same as previous one. They are showing, ma'am.
Okay. So the teacher's time slot is shown over there.
Ma'am, all time slot it's showing, ma'am. From morning 10 to night.
I am not aware about it, but actually I'm not free throughout. Obviously, they are showing it because they haven't communicated with me about it. But I honestly will not work with these monthly classes because they are creating so much mess in between during the payouts to the teachers. Even they are not giving it completely, so that is the point. Even from one of my student who was taking private classes from Meena, they were like, when the session, they just given me few classes to complete the syllabus, and I even tried as much as I can to complete the syllabus of that student. And they means how much classes they have given, I have just completed it priorly so that I can utilize the time for the revision of the student. And they are like, okay, you did the syllabus, so we are not giving you more classes now. It's like whatever classes is finalized, they are not even giving that as well.
Yes, ma'am. This was I also faced it, ma'am. When if teacher, ma'am, any tutor, ma'am, if they complete within if 20 were given, ma'am. If ma'am completed in within 12 classes, my max madam also said that in 8 classes we will discuss some hard questions which require interactions like that, ma'am. Immediately they said that syllabus completed, we have not responsible.
Yeah. Same thing they do right now as well. They are not providing even the classes. But one student is there who takes private sessions from me, and that student is quite powerful. You can say powerful in the sense his father is very close. We can say close friend of that CEO, I guess. So that is the reason that student is provided with surplus classes, and they are not at all providing any objections to them. Also, they have created a group in which their parents are also included in that. Although that is not allowed because it's not for any other student, but that particular student is getting a very special importance. So we have holding their parts accordingly. For that student, they can give the revision classes as well. They can give the test properly to them. They can give the classes more to them. So they can do anything for that student because he is quite powerful.
But it's not a correct thing, ma'am.
Exactly.
It's a student's life which depends on.
I'm having 12th class 2 student. I was having 12th class 2 student, but both of them are joined me at the same time. One student is provided with 90 classes, and another student is provided with only 40 classes. See how much we can say unjusted they are doing, right? Same, both same, everything is same. Same times they are joined, same amount I'm getting from the two. So it's like, why is it so special treatment given to one student and not to another one? Just because so that doesn't mean that you are giving the partiality to him. Just give that thing to each and every student, right? So that is why I'm having very much to school. So even do not continue that private classes or whatever is going on as of now. I'm just doing that only.
Yes, ma'am.
So okay, so Himansh, let's continue then.
Yes, ma'am, you can continue.
So the next preparation is from L5. From L5. From L5. Method of preparation from alkyne. So alkynes are two types of preparation we will do. First preparation is Lindlar's catalyst. Lindlar's catalyst. So in Lindlar's catalyst, what actually happens is, and poisoned with quinoline or poison with quinoline or xylene or partially activated paralyzed charcoal. So it's like, what is Lindlar's catalyst? H2PD BaSO4. This catalyst supporter, that is known as Lindlar's catalyst. Palatine charcoal is like this. Lindlar's catalyst. This is Lindlar's catalyst. Got it? Himansh?
Yes, ma'am, got it, ma'am.
So we are having an alkene, let's say, alkyne, like this. We are supplying to it H2, PD, BaSO4, sulfur or quinoline, and we are getting cis alkene. That is very important. Alkene, that is cis alkene. So stereochemistry is that we are getting cis alkene in this Lindlar's catalyst production. Got it? Yes.
Yes, ma'am, got it.
Cis alkene or stereochemistry, you can say syn addition. In stereochemistry, we will say that what happening is syn addition. Due to syn addition, syn means hydrogen added from same side. So we are getting cis alkene. Got it or no?
Yes, ma'am, got it, ma'am.
So here, what actually happens is this. We can say poisoned. Written the word, you know what? Poisoned with quinoline, xylene, or partially activated palladized charcoal. So they all are deactivating the catalyst. Why is it so? Because this alkene can further be attacked by more hydrogen, right?
Yes, ma'am. Means they are decreasing the rate at which they are attracting.
Okay. Second preparation we can say is using E2 catalyst. That is nickel bromide, boride. Nickel boride. When we use this nickel boride now, when actually it will also do the same thing. Just copy paste of the previous one. So we will get okay. So both Lilac and E2 catalyst cannot catalyze alkene to alkane conversion. Got it? Both of them is unable to show this. Okay or no?
Yes, ma'am. Okay, ma'am.
Our next reaction is Birch reduction. Third year. Birch reduction. What is there in Birch reduction? That we are using the reagent. I'm taking a second class parallel along with it. Himansh,
Yes, ma'am. Okay, ma'am.
you want to start any other, or if you want me to continue this only?
Ma'am, we can continue organic only, ma'am. So that we ma'am, we'll continue organic chemistry only, ma'am.
See, if you want, because I up over here taken your class, 2 classes a day, right?
Yes, ma'am.
According to, if you want to take a more shot, that totally depends on you. Himansh. Tell me.
Yes, ma'am. I can take, ma'am.
What? 3 classes. Huh?
Yes, ma'am. Okay, ma'am.
You can take, I can manage somehow the timing for you. Manch. If you want 2 classes or 3 classes, what's it?
Ma'am, I can take 3 classes so that fast rate can complete.
Hello?
Ma'am, I can take 3 classes, ma'am, so that syllabus will be completed fastly.
Okay. So I need to adjust the timings for you now. Because from 11 o'clock I can take that classes. Okay? 11 a.m. So we will also keep a record in as well, Imansh. Okay? That classes, if any class is missed from my end now, I will accordingly reschedule that class from my end. And if you want to take any of the leave from your end, you just update me one day prior to it. I'll reschedule the class.
Yes, ma'am. Okay, ma'am.
Okay, so it's fine enough.
Yes, ma'am. It's fine.
11 a.m. Rest of the day are okay. Yeah. I'm available at 11 a.m. We will take our class and see for other timings, whatever be convenient according to that day. Right? So we will set our target to take 3 classes a day.
Yes, ma'am. Okay, ma'am.
I will schedule 10 more classes, and you will if you take 10 classes, I need to schedule for that or any other. How much classes you want me to schedule?
20 first, and after that again 20 like that.
You already scheduled your 20 classes according to two slots a day. After that, you tell me that how many classes more need to schedule.
Yes, ma'am. Today I will message you, ma'am. How many?
Huh?
Ma'am, today I will message ma'am again how many need to schedule. Yes.
Let's discuss about boil reduction. So reagent is Na liquid ammonia or lithium ROH is alcohol. So what it actually do is we are having alkyne, sodium and liquid ammonia. So it will create it to alkene. But the alkene over here is trans. This is the trans alkene. Got it or no?
Yes, ma'am, got it.
So let's discuss about the mechanism separates over here. That why is it so we are getting the trans? So see, R C triple bond Cr, sodium. Sodium will donate 1 electron. So here carbon takes that electron density. This carbon got a positive charge. This positive is attacked by this electron, so we are getting R C getting a negative charge. This carbon got a radical and R. Either you can do this thing or they arrange them in this manner like this. Right? Image. So in this condition, repulsion in between them. No repulsion. That is the reason that we are taking this as well, right? And when we attack NH3 means like this. So H positive will be donating that, will take that electron density from the negative, and it will convert to structure like this. H, R, this radical. Radical will get one more electron from Na, and again convert to Na positive and electron. That electron will be taken by this radical, and it will together form a negative charge. This negative charge will be further attacked over by NH3. Right? NH3 will further release H positive, and that H positive get electron from this negative, and ultimately we will get this structure like this. Got it or no?
Ma'am, in presence of any, that's triple bond converts to double bond, ma'am. You can explain this mechanism again.
See, what happened is the first step we just shifted one electron pair to any one carbon because both the carbon are same only, so I have migrated it over here. So this carbon got a negative and this carbon got a positive charge. When this carbon got a positive charge, that positive being converted to neutral because of this electron. Because see, Himansh, when a species is having a positive charge, that taken the electron now, that the positive charge will ultimately remove, no? Correct? When positively charged species accepted an electron, so the charge removes. Right? So this carbon got a radical, right? Because of 4 valence electron. Remember in inorganic we did discuss 4 valence electrons.
Yes, ma'am.
Now this carbon radical and negative. If they both are very close to each other like this, there is repulsion. But they are opposite, so there is no repulsion. That is why we have got this structure, not this structure. Then this negative is taking H positive from NH3. Negative taken H positive from NH3.
I mean, to avoid the repulsion, that's why we're shifting this to lower, we can say.
With that radical which is formed over here, now taken one more electron of sodium. When you taken one more electron of sodium, it will be converting to negative charge, because neutral when taken electron got a negative charge. So that is required. This carbon got a negative charge. When this carbon got a negative charge, just a second. So when this carbon got a negative charge, it will again accept H positive from second NH3 molecule. So that is how we can say 2 Na and 2 NH3 are used, and together it will form NaNH2. Got it or no?
Yes, ma'am, got it.
So this is the internal alkynes. Internal means triple bond is on internal carbons. Right? Any problem, Himansh, so far?
No problem.
So birth reduction is not. Note point is birth reduction is not used for 1 degree alkynes. 1 degree or 1 alkynes. Means we can say terminal alkynes. Now the question is why? See, terminal alkynes, this hydrogen is acidic hydrogen because it is having sp carbon, na? Acidic hydrogen because this carbon is sp hybridized, right? Sp hybridized is having 50% S character, which is making it to be electronegative. Got it, Himansh?
Yes, ma'am, got it.
That is why we will say that it will not show birth reduction, otherwise that liquid ammonia that we are using now, or sodium metal we are using, it will show that acid base reaction. Acid and metal reaction. To produce salt and hydrogen gas. So there is a salt which is formed, which is inactive to then do the alkene formation. Is it clear?
Yes, ma'am, clear now.
And if we do take, now if we take H2PT, PaSO4, sulfur or quinoline, we are getting accordingly an alkene, that is Lindlar's catalyst. Then we are getting it. But if we are doing the same reaction with sodium liquid ammonia, so we will say that no alkene due to and formation of salt. Formation of salt. Alright.
Yes, ma'am.
Now if we are applying Lindlar's catalyst to this, in Lindlar's we know that we are getting cis alkene. So this will be the final answer, right? Cis alkene. This is also cis, this is also cis. But if for the same we are taking sodium and liquid ammonia, then we are getting trans. So trans is like this. This is the trans alkene. This is also trans, and this is also trans. This is cis, and this is cis. Got it?
Yes, ma'am. Got it.
Okay, although we will discuss about production in aromatic compound also, but I will discuss it now only because we have already discussed the mechanism. Although we are discussing alkynes, but in aromatic compounds also cross reduction happens. So sodium liquid ammonia. So since we are discussing this reaction cross reduction, so I'm covering that as well over here only. So it is forming this type of double bonds. 1,4 di. Okay, 1,4 di. Now let's discuss about the mechanism which operates over here. Like why is it so? So basically, we are having this sodium converts to sodium positive an electron. So if let's say we are migrating a bond over here, so we are getting a negative over here, bond, a radical over here. This radical will do the resonance, and negative over here, bond over here, radical, newly formed radical, and this radical will make a bond like this, right? And a radical will be created over here. Is it clear or no, Himansh?
Not clear, ma'am.
After this, NH3 will supply the hydrogen over here. We will get a radical. Sodium will also be there. Sodium will convert again to Na positive and electron. So this will convert to a negative. And finally, one more NH3 will be there which supply hydrogen to this as well. So that is how we are getting the hydrogens over here. Got it?
Ma'am, can you explain this again?
Okay. See. First step is clear to you. Bond shifted over to this carbon. They got a negative charge over here. This carbon got a negative charge over here. And this carbon got a radical. Radical means because this carbon got a positive, positively carbon taken that electron from Na and create a radical. Now this radical will do the resonance with this double bond. Double bond is breaking in a homolytic region. So we are creating a radical over here, another radical over here. That radical and radical create a bond in between, and we are getting a new bond like this. and a new radical will be over here in this position like this. Then NH3 will give that NH3. What is the function of NH3? NH3 function is to supply H positive to this negative carbon. And I've drawn two steps in a single go. So first is NH3 given H to this carbon, and second is Na given one more electron to this radical, and it will convert it to negative charge, right? Himansh?
Yes, ma'am.
This charge over here is attacked by H positive, negative positive, again make a bond, and this is how we are getting the 1,4-diene, cyclo-1,4-diene. Got it? Got it?
Got it, ma'am.
In any step. Yes, Himansh.
Yes, ma'am. We can.
Down.
No, no doubt, ma'am. Got it.
Now moving on to OCH. OCH. Now have a look. If a group is present, so how it will affect? So it is if any plus R showing group. Any group that shows plus R. If we do the same thing, sodium in liquid ammonia. Now what will happen now? That diene which is created is along to the group like this. Okay. Why is it so? The reason behind it is, see, since it is plus R, so it will not break the bond over here. Since the group is showing plus R, na, Himansh? Group is showing plus R. So bond cannot be shifted over here because it is showing plus R. So bond shifted over here only. Right or no?
Yes, ma'am. Right, ma'am.
Plus R of OCH. It will destabilize negative. Right? So bond will migrate over there. So you will get a negative over here, OCH3 over here, a radical over here, other bond like this. Again you will split it now and you will get a radical over here, bond over here, OCH3 over here, NH3, and Na will attack now. Na will make a negative over here and NH3 will supply proton and you will get this alkene now. Is it clear or no, Himansh? Tell me. I'm just repeating the things. Negative giving negative is applied NH3 supply H positive to this negative, and this radical will get electron from Na, and again NH3 will give H to this.
Ma'am, why, ma'am, it will shift in this opposite direction?
This direction. Which direction? Yeah, in the first step.
Yes, ma'am.
If it migrates over there now, let's say. If negative moves over here, like this. A radical created over here, let's see. Now what will happen now? This lone pair is electron donating and it is already having electron density, electron height. If we whenever see, whenever we want to stabilize a charge, we have to see that what charge actually there is. If it is negative charge, means negative charge is stabilized if the group is electron withdrawing. Electron withdrawing group will stabilize negative charge, right? Na, Himanshi?
Yes, ma'am.
So OCS is not electron withdrawing. It is electron donating group. It donates the electron. So it will make the negative unstable. Right or no?
Yes, ma'am. Right.
Any problem, any doubt, Himansh, so far?
Ma'am, no problem, no doubt.
Oh. Okay. And if let's say we are having electron withdrawing, now the bond will be migrated to electron withdrawing group. Electron withdrawing group minus R. Now the bond will be migrated to this side only. And since it migrates to this side, so this will get a hydrogen, and we will accordingly know that wherever hydrogen moves, so this will be the structure. Right now, because NO2 group stabilize the negative charge due to minus R. Okay.
Yes, ma'am. Okay.
Let's take a question now. Let's say we are having a 10-member ring. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. We are handling Lindlar's catalyst, and we are adding Birch reaction. We are doing Birch reaction. But we know that in Lindlar's crystalline is formed, right? So 10 is shown to be like this. And in this Birch reaction, we'll create it like this. So this is trans, and this one is cis. Got it?
Yes, ma'am. Got it, ma'am.
Will you analyze those how many proportions are given to you, Himansh?
Ma'am, I have not checked, ma'am.
You're having it now? Or no?
I'm not having, ma'am.
जो काफी मिन्नतें करने के बाद
Give me a second, Imanch. Let me check once. In your Narayanas, I can see that. See, in that alkenes as well, they have mentioned E1, E2 and over there as well.
Yes, ma'am. It's initially they're given in.
Alpha elimination, beta elimination, gamma elimination is also there. You have read from the book or not?
For concept, I will not follow this book, ma'am.
Alpha, beta, gamma elimination we didn't cover. Beta elimination I told you, but not that alpha elimination or gamma elimination, right? Na?
Yes, ma'am.
No issues. That is not that much important. Okay. So after that, which other preparations are left is, one is cracking of alkenes. Preparation is from cracking of alkene, that is pyrolysis. In that cracking of alkene, see, basically what happens is, if we are having higher alkenes, like butane, if we do cracking, means we are heating it to high temperature, 773 to 973 Kelvin. So we are getting mixtures, alkanes, alkyl alkenes. So we are getting this alkene and ethane, or two carbon like this, ethene and ethane. If we are having, let's say, hexane and hexane, 2, 3, 4, 5 and 6. We are doing cracking, means we are providing very huge temperature to it. So there is a possibility of 3 carbon, like one is propene and another one is propane. Like this. Got it? Okay, Himansh.
Yes, ma'am.
Another reaction, one more reaction is there, that is always electrolysis, ma'am. Next reaction is always electrolysis. Always electrolysis. So, in always electrolysis, we are having dicarboxylic acids. We are using over here dicarboxylic acid. Potassium salt. Like we are adding water to it and we are doing electrolysis. When we are undergoing electrolysis of it, we are getting alkene. CO2 is removed out, hydrogen gas removed out, and KOH is removed out. So how it actually happens? Let's discuss about the mechanism of it. First of all, there is the ionization. CH2COOK, CH2COOK. It do the ionization. When it undergo the ionization, it will be CH2CO minus, CH2CO minus, and 2K positive. Right? Also, water is present. Water will also do the ionization. H positive and OH negative. At anode and cathode, the respective reactions happen. The anode, what actually happens is the CH2CO minus, CH2CO minus. See how it actually does the reaction. It will remove 2 electron out. Remove 2 electron out in this CH2COO radical, CH2COO radical. Very interesting step, just look into it. That over here, they will also do the radical mechanism. And this carbon which get a new radical, bind with one oxygen and create CO2. And this CH2 having one radical now combine with each other to create a new bond, and CO2 together removes out. Getting that or no? Himansh? Is it clear?
The radicals will form on CH2 double bond CH2.
Combine with 2 electrons. H positive over here, no? That 2 electrons will be accepting by this H2 and it will convert to H2 gas, hydrogen gas. Okay? Because E0 reduction potential of hydrogen is higher than E0 reduction potential of potassium. Got it, Himansh?
Yes, man, got it.
Any doubt in this?
No doubt, man.
Next is one more reaction, last reaction, method of preparation, which is Wittig reaction. So, aldehydes or ketones, any carbonyl compounds, reacts with phosphorus halide. although the reaction is not there in your NCRT, but it's given that phosphorus halide. This is phosphorus halide. Heated and heating the thing. This is short. Okay, you want me to tell the mechanism for this reaction, although there is no requirement of the same, but if you want, I can give you the mechanism as well. This is short trick to remove this oxygen out, DPH3 out, and combine the CH2 over here. This is the alkene which is forming acid. Tell me, Manch.
Yes, ma'am, got it.
Any problem in that?
No problem.
You want me to give the mechanism, or is that okay for you?
You can explain mechanism also.
What?
You can explain mechanism also.
No, like mechanism is like, see, this is a carbonyl group, and this is a phosphorus halide like this. Like this. So just this oxygen, see, kind of cyclic structure we have to form like this. Okay, so carbon, CH2, DPH3, oxygen, like this. Got it? It will create a bond over here, and it will create a bond over here. Like this. Got it or no? Himansh.
No, got it, ma'am.
Although one more is given, pyrolytic elimination. So pyrolysis of esters. Pyrolysis of esters. What is the meaning of pyrolysis? Just remember, pyrolysis means heating in the absence of air. Heating in the absence of air. That is pyrolysis. So, let's say we are having an ester. We are heating it. When we are heating it, we are getting what? CH3. We just broke this bond out. CH2 double bond CH2 and CH3 C double OH. We are getting like this. Okay.
Yes, ma'am. Okay, ma'am.
So let's say we are having this other type of let's say like this, heating it. So this is, we have to consider that we are breaking this bond out, right? We are breaking this bond out When we break this bond, this is alpha carbon and this one is the beta. This one is also beta. But which alkene we will create? This is crowded. This is less crowded. So that is why we will eliminate this out and we are getting this alkene. Hoffman product. Got it? Himansh?
Yes, ma'am. Got it, ma'am.
The mechanism is even. Stereo is syn elimination. Regio selectivity. Regio selectivity means Hoffman or Caesar, so it is Hoffman part. Alright, Himansh.
Yes, ma'am.
If you want me to show that how it is happening, have a look. CH3, CH2, CH having CH3. CH3 I can write it like this. O, C, O, CH3. Like this. So now, this oxygen makes a bond over here. This will make a bond with hydrogen. Hydrogen break the bond and create over here. Getting it like how it is happening. This bond creation over here, just like carbon got a new bond, it broke the old bond with oxygen. And oxygen hydrogen will create a new bond. The hydrogen break the bond with carbon and shift it to carbon-carbon double bond. When this carbon got a new bond, it will break the bond. Is it clear or no?
No, once here OH hydrogen bond is forming, we are seeing, ma'am. Hydrogen is forming bond. OH bond will be hydrogen bond, we are saying, ma'am.
Not hydrogen bond. Hydrogen bond is a temporary bond, but over here we are completely creating a bond, right? Hydrogen bonding is just the affinity, we can say. But here we are actually creating a bond in between the two, right, Himansh? So oxygen and hydrogen, a new bond is forming, and CH2 creating a new bond with hydrogen. C2H5. This is CH3. So ultimately, this is a transition state where temporary bond are shown, like new bond or old bond are creating or destroying. So cyclic transition state, we can say more pronouncedly. Cyclic 6-member transition state. That is why prefer less crowding. That is the reason we have selected that carbon, beta carbon, which is less crowded, less important. And ultimately we are creating CH3, CH2, CH, double bond, CH. Clear, Himansh?
Yes, ma'am. Clear, ma'am.
Second in this is co-rearrangement, co-elimination. Also we name it as EI elimination. It is also given in your Narayana as well. Co-elimination, but let me check that how it is given over there. Co-elimination. So what happens over here is, let's see, hydrogen bonded to 3 other groups. Like this. So this is a 3-degree amine. Let me write R or R dash. Here we are supplying H2SO5 means per acids. Per acid, that is strong oxidizing agent. It will do what? It will basically oxidize nitrogen, positive, negative, like this. So when we heat it now, what will happen? We will get Hoffman product. Less substituted, more crowding. This beta na, alpha, beta and beta. More crowding, and this is less crowding. Got it?
Yes, ma'am, got it.
Or we can say minus eliminating out. Like R dash, R dash. So mechanism is EI. Okay na? Any problem?
No problem.
This is also sin elimination. Last reaction of Hoffman elimination. Here what actually happen is, we are having a mine, methyl iodide. It was asked that in your TYQs as well, this reaction. Moist, directly they just apply HAG2O, moist Ag2O. So moist Ag2O gives us an idea about this reaction which is proceeding over here. Again we are getting Hoffman as a major product. Product as major. And other N containing CH3, and CH3. So here the mechanism operates is E2. Anti-planiplanar elimination, anti-planiplanar elimination happens, and the ratio selectivity is Hoffman. Okay?
Yes, ma'am, okay, ma'am.
I told you that N, this is this group. When N positive, right? When N positive is there, it's a poor living group. And when poor living group is there, you will say Hoffman product will dominate. Remember? Here also, we again and again supplying methyl iodide. Methyl iodide will ultimately. You want me to tell the mechanism of it as well, or no?
Can you tell mechanism also?
Okay. The mechanism is like NH2. So just we are doing exhaustive methylation. Means methyl iodide, nitrogen have lone pair, it supplies over to methyl, it will eliminate. So it's like NHCH3. H and I from here eliminate out. Again we are supplying one more methyl iodide, nitrogen have lone pair, it will supply to carbon, I will again eliminate. So it is NCH3 twice. Again nitrogen contains lone pair, HI eliminates. Again we are supplying it to CH3I, Nitrogen attack to CH3. I eliminate, and we are again getting NCH3 thrice. Now nitrogen got a positive charge, so it becomes a poor leaving group now. And as I told you, poor leaving group will produce Hoffman product to be the major product. Remember?
Yes, ma'am. Remember.
So when we are providing moist Ag2O, means what's the meaning of moist Ag2O? Means AgOH, right? So basically, it will eliminate out like this, and we will get a major product like this. Got it?
Yes, ma'am. Got it.
If we are having, let's say, this type of structure, and we are again providing the same thing, methyl iodide, Ag2O, moist, and heat. We are now getting this nitrogen again and again attacks over here, right? So you're getting this type of alkene, one over here and one over here. Okay? Himansh.
Yes, ma'am. Okay, ma'am.
So next coming class we'll discuss about physical properties of preparation is all done. Okay?
Yes, ma'am.
That's all for today's class.